Okay, there we go. So now it's right under the daily agenda. So I have chapter 3A packet, and notice I have for printing here. This is a digital typable document, but as far as notes are concerned for this unit, I've entered this packet into something called ClassKick. Has anyone used that in any of their other classes? Okay, some of you have, some of you haven't. The reason I've done it for this unit is because there's a lot of places where you're going to want instant response to your answers, and I can set it so that it will tell you if you're right or wrong. Okay, so you'll know if you're doing it right. So if you want to print this out just so you have a hard copy of it, you're welcome to. If you want to fill it out, it is fillable. So if you want to do it in ClassKick and then go back and practice in here, you're welcome to, but it's not required. Okay, so all of these fields you can type into, but again, it depends on how you like to keep your notes. Okay, so today we're going to just start with the very beginnings of the chapter. So the things we're going to cover in this chapter are something called significant figures, scientific notation, which you should have done a little bit before, but we're going to go back over that. The difference between precision and accuracy, how we figure out what the error is in our results, density, and then how to correctly record measurements. So the first thing we need to tackle, and this is, while this is not hard, this is something that students hate because it's going to bite you in the butt all year, because every time you write a number from this day forward, you're going to have to think about something called a significant figure. Okay, so what is a significant figure? When we write numbers, the digits, individual digits within those numbers have meaning. Some of them have more meaning than others. So for example, if I said the number 312, the reason I'm saying the 3, the 1, and the 2 is because that's probably an exact number. I know that I have exactly 312. Otherwise, why would I say 312? Okay, that's not just a random number. But let's talk about if I saw a crowd of people and I said it looks like there's about 300 people in that crowd. Okay, so that number 300 has a different level of significance because I don't know exactly that it's 300. Okay, so in that case, some of those digits have more significance than others. But let's talk about that same crowd. Now let's say I actually counted every single individual in that crowd and there were exactly 300 people in that crowd. Okay, now those digits take on a different significance, because if I know that it's an exact number versus an estimate, I can say for sure that I know those zeros are true values and not just an estimate. Okay, so this is kind of confusing. So we're going to start by first just going over the rules so you know which numbers are significant and which aren't. And then we're going to show you some examples of why it matters. Okay, we're going to apply it to science so that you can see why it's important that we follow these rules. So I am going to show you a video, and you can just watch for now because all these rules are going to be written out for you on this sheet. And we're going to go through the first 3 rules and then we're going to stop. Okay, so just hang tight and watch.
Welcome to my video on significant figures. In this video, I'm going to talk about all of the different rules which show us how to count the number of significant figures. I will be making a separate video explaining why significant figures are so important and why we use them. But in this video, I just want to go over a bunch of examples which will hopefully show you how to count the number of significant figures. So I wrote for you 4 different rules. Let's start with rule number 1. And rule number 1 says non-zero numbers are always significant. I think this rule is pretty self-explanatory. It's probably the easiest out of the 4. So let's go over some examples of this. Let's say we have the number 1.23. Let's say we have the number 45.6. And let's say we have the number 7,263. So let's start with the number 1.23. All 3 of the digits in this number are non-zero. So we know that non-zero numbers are always significant. So this number has 3 significant figures. And the same idea for the number 45.6. All 3 of the digits in 45.6 are non-zero numbers. So we know that this has 3 significant figures. I think you get the idea by now. The number 7,263 has all non-zero digits. So all 4 digits are significant. So we have 4 significant digits. So I think we spent enough time for rule number 1. Now let's go over rule number 2. So rule number 2 says that in between zeros are always significant. Once again, I think this rule is pretty self-explanatory. So let's go over some examples of this. Let's say we have the number 1.0005. Let's say we have the number 70,206. And let's say we have the number 1,507,000. So let's start with the number 1.005. We know that the number 1 and the number 5 are significant because they're non-zero digits. And all these zeros are in between those 2 non-zero digits. So like I said in rule number 2, in between zeros are always significant. So anything between these 2 non-zero digits are significant. So all of these numbers, 1, 2, 3, 4, 5, are significant. Let's do our next example, 70,206. We know that this digit 7 and this digit 2 are non-zero digits, so they are significant. This 0 is in between them, so we know that's also significant. We know that this number 6 is non-zero, so it's significant. And this number 0 is in between them, so that's also significant. So we have 1, 2, 3, 4, 5 significant figures. Moving on to our next example, we have the number 1 and the number 5, which are non-zero digits, so they're significant. And we have the 3 zeros, which are in between them, so we know that they are also significant. We have the number 7, which is non-zero, we know it's significant, and the number 0, which is in between. So all of these digits are significant. So we have 1, 2, 3, 4, 5, 6, 7 significant figures in this number. I think that's enough for rule number 2. Now let's move on to rule number 3. So rule number 3 says that leading zeros are never significant. Once again, leading zeros are never significant. So let's go over some examples. Let's say we have the number 0.000055, and let's say we have the number 0.000302. So first let's talk about leading zeros. A leading zero is always to the left of the non-zero digit. So our first non-zero digit in this number is 5. So all these zeros to the left of the 5 are leading zeros. So we know that these numbers are not significant, and we know that the 5 is significant and this other 5 is also. So this number has 2 significant digits.
Okay, I want to pause there for a second because I don't like the way he crosses these zeros out. Just because a number or a digit is not significant doesn't mean we don't write it. Okay, so those zeros don't just disappear. They are important in that they hold places so that we know that this 5 is at the 10,000th value. Because if we didn't write those zeros, this number would be 55. Those zeros show us that this is a much smaller number than 55. So even though they are not considered significant in terms of value, they do still get written because they're there for a reason. Okay, so just know that just because a digit isn't significant doesn't mean it disappears. It's still there.
Now let's go over this next example. Our first non-zero digit is 3. So all of the zeros to the left of the 3 are leading zeros. So all of these zeros are not significant. And this 0 is actually in between the 3 and the 2. So that's an in-between. We know that is significant. And the 2 is non-zero, so we know that's also significant. So this number has 1, 2, 3 significant figures. So that's enough for rule number 3. Now let's go.
Okay, so we're going to stop at rule number 3, but I want to just do a quick check here. So you can use your fingers to show me your understanding here. I'm going to write a number on the screen, and I want you to count the significant figures and put it up. So remember, non-zero digits, anything that's not a 0 always counts as a significant figure. In between zeros, sometimes I call those sandwich zeros because they're sandwiched between 2 non-zero digits. They always count. And leading zeros, which are in the front, which come before your first non-zero digit, never count. They aren't significant. Okay, so let me put up an example here. Okay, take a look at that one and tell me how many sig figs there are with your hand. Sig figs is short for significant figures. Okay, let's have 100% participation here. It'll wake you up. Raise them high, put them in front of your camera. I am missing some hands.
I didn't get the number pop up in the chat.
You what?
I didn't get the number in the chat.
Oh, it's not in the chat. I actually wrote it on the screen.
Oh, okay.
Yeah. Okay, so it is 4. We've got these non-zero digits, which are always significant, and then this one's between. So that is an in-between 0, so that gives us 4. Okay, good. Here's the next one. How many significant figures? Okay, good. So there are 4 non-zero, non-zero. These 2 are sandwiched, so they both count. Here's our first non-zero digit, and all of these are in front, so they are considered leading, so they don't count. So we have 1, 2, 3, 4. All right, do we think we want to do another one, or are we good? Give me a thumbs down if you want another one. All right, I don't see any thumbs down. It's going to get a little more confusing tomorrow when we introduce the last rule. Okay, so we'll do a lot more practice tomorrow once we introduce that final rule. All right, so I'm going to let you